So question number 9. So here it says a farmer is growing field of rice plants. The height of each plant can be modeled by the normal distribution with the mean and standard deviation. So you can see that we are already talking about the normal distribution. That means this is a topic 4 questions. Okay, so this is derived from the topic 4 of your curriculum. So there's another information here. So it is known that the probability of height less than 82.4 is 0.213. The probability of height bigger than 87.3 is actually equals to 0.409. So question A, we need to find the probability that the height of the randomly selected plant is between 82.4 centimeter and 87.3 centimeter. So since this is a normal distribution, so far we have a normal distribution, right? Because we are just talking about one variable. So let's do this question in a new page. It is known that probability that the height is less than 82.4 is 0.213, and the probability that height is greater than 87.3 is equal to 0.409. So we need to find the probability that the height of the randomly selected plant is between 82.4 and 87.3. So that means we actually have to calculate the probability that the height of the plant h is between 82.4 and 87.3. Okay, so since the normally distributed case has a symmetrical graph like this, we can say about at this point we have a value of 82.4, and about right here we can say we have a value of 87.3, right? So we are trying to calculate the area between these 2 points, and we already know that the area here after 87.3 is about 0.409. The area below 82.4 is about 0.213, and since everything under this graph adds up to 1, we can say that the probability that height is between the 82.4 and 87.3 is equals to 1 minus 0.213 minus 0.409. So it is equals to 0.378. So the probability that the height is between 82.4 and 87.3 is equal to 0.378. Okay, then let's try question B. So question B, we need to find the mean and the standard deviation. So okay, we need to find the mean and standard deviation for question B. So since this is a normal distribution question, okay, so since you're missing two values like mean and standard deviation value, and this is case of the normal distribution, right? So when you miss these two values, you have to use the standardization concept to identify these two values. Means you have to do the Z-score testing, okay, using Z value equals to x minus mean over standard deviation. Okay, so let's do this question 2 together. So question B, we already know the two information, right? So p value is equal to h less than 82.4 equals to 0.213, and probability that h is greater than 87.3 and is equal to 0.409. Okay, so using these two information, we need to set two equations to solve these two unknown values. Okay, so in order to do that, we're going to use the inverse norm function to calculate the Z value, okay, for both cases. Okay, so for the first case, we know that area is 0.213, And to standardize, you have to use the mean value equals to 0, standard deviation value equals to 1. Okay. Then using your GDC, we can do second distribution. So you have to do second distribution. So you do inverse norm, and you set area at 0.213, mean value as 0, and standard deviation value as 1. Then you get your Z value equals to negative 0.79605. For the second case, since h is greater than 87.3, right, some of your calculator doesn't recognize this inequality in the probability. So what you need to do is, instead of using the area equals to 0.409, you always have to consider the case as probability h less than 87.3. So you do 1 minus 0.409. Okay, then this value is equal to 0.591. And of course, some of your calculator does recognize this inequality. So in those cases, you don't have to worry, right? So make sure you check your calculator, and you can still set the mean value equals to 0, standard deviation value equals to 1. So you do second distribution, inverse norm, and you set your area at 0.591, mean value equals to 0, standard deviation value equals to 1. Then you get your z-score value equals to 0.230118. Okay, now you can set two equations using this information with the formula z equals to x minus mean over standard deviation. Okay, then you can do negative 0.79605 equals to your x value, which is 82.4. 82.4 minus mean divided by standard deviation, and your second equation going to be 0.23018 equals to your x value 87.3 minus mean divided by standard deviation. Okay, then you can rearrange this equation as minus 0.79605 standard deviation equals to 82.4 minus mean. Then mean value is equals to 82.4 plus 0.79605 standard deviation. And for the second part, it is equal to 0.230118 times standard deviation equals to 87.3 minus mean. Then mean value is equal to 87.3 minus 0.230118 standard deviation. Since we know that both equations are actually equals to mean, right? Then we can set these two equations to equal to each other. Then we do 82.4 plus 0.79605 standard deviation equals to 87.3 minus 0.23018 standard deviation. Okay, then rearranging this equation will give us the equation of 0.79605 standard deviation plus 0.23018 standard deviation equals to 87.3 minus 82.4. Then this is equals to 1.026118 standard deviation equals to 4.9. So standard deviation value is equal to 4.775. So we can say that standard deviation is approximately equals to 4.78. Okay, then once we got the standard deviation value, we can substitute this value into the one of the equation, right? Then the mean value is equal to 87.3 minus 0.23018 times 4.775. Then this is equals to 86.2 2009. So we can say the mean value is approximately equals to 86.2. Then let's do question C. So we have more information. The farmer measures 100 randomly selected plants. Any plant with a height greater than 87.3 centimeter is considered ready to harvest. Heights of the plants are independent of each other. So question CI, we need to find the probability that exactly 32 plants are ready to harvest. So in this case, we actually have a binomial distribution. So I think we need to, at this point, have to discuss how to identify the binomial distribution, right? So in a binomial distribution or any binomial probability experiment, we always have a fixed number of independent trials. Two, we always have two possible results, only two possible results. So it means pass or fail. Or three, we can have the probability of the success is the same for each trial. Okay, so here in this question, question C, the farmer measures 100 randomly selected plants, and any plant with a height greater than 87.3 centimeter is considered ready to harvest, right? So height of the plants are independent of each other. So this is like harvest or no harvest case. So that's the reason why this is considered as a binomial distribution. So question C, we need to find the probability that exactly 32 plants are ready to harvest. So since we have a binomial distribution case, let's identify this as binomial distribution first, okay? So from the previous question, we know that probability of plant has height greater than 87.3 is equal to 0.409, right? So since we need to do the binomial distribution of where the probability that x is equal to 32, x means the number of the plants that was harvested, right? We're going to first identify this x value as the binomial distribution using the binomial distribution notation. So it means we have to do x, and this is binomial distribution with the total number of the 100 plants and the probability of the 0.409. Okay, then once we are done with identifying the problem as a binomial distribution, we're going to use binomial PDF function from UGDC. So using the second distribution again, we're going to go to binom PDF, and you're going to enter your value. So first value will be your total number of the sample, right? After that, you're going to identify your probability, which is 0.409, and you're going to identify your x value, which is 32. Then you get the final answer of 0.0157931. So the probability that x is equals to 32 is equals to 0.0158. Then question CII, given that fewer than 44 plants are ready to harvest, we need to find the probability that exactly 32 plants are ready to harvest, right? So since the question starts with given that means this is a conditional probability. Okay, and that means we have to calculate the probability that the number of the plants got selected is equal to 32 when plants that are fewer than 44 plants are ready to harvest. So we do x is less than 44. Okay, and this is equals to probability that x is equal to 32 over probability that x is less than 44. Okay, so probability that x is equal to 32 is already calculated from the previous question, which is 0.0157931. However, we are not sure about this probability, right? So we actually have to calculate it before finding the final answer. Okay, so again, since this is a still binomial distribution, we have to change the probability that x is less than 44 to probability that x is less than or equal to 43, so you can use the binomial distribution. And then since this is the inequality, instead of using PDF, you're going to use the binom CDF. Okay, so using the binom CDF function on your GDC, so we do second distribution and we go to binom CDF and we're going to set m value as 100 and probability still 0.409, and we're going to set our x value as 43 because this is inequality. Okay, then it will give you the answer 0.702975, and this is same as probability that x value is less than or equal to 43. So we can substitute this value here now. Zero point 0.0157931 divided by the 0.7029, and it will give you the value of 0.022466. So we can say that probability that x value is equal to 32, given that the probability that x is less than 44 is equals to 0.0225. Okay, then let's try the last question, the question D. So we have another set of the information here. So in another field, the farmer is growing the same variety of the rice, but it is using a different fertilizer. The heights of these plants, F centimeter, are normally distributed with the mean 92.8 and the standard deviation D. We need to find the value of the D, standard deviation value. And the farmer finds the interquartile range to be 4.52 centimeter. So let's do this question in a new page. So we know that interquartile range is 4.52, the mean value is 92.8. Then we can say that since the mean value is 92.8, and we do know that the interquartile range, let's say this is the red line is our IQR, then we can say that the Q1 value to Q3 value, the interquartile range is 4.52. So means since between the mean and the Q3, we know that Q1 is 25% away from the mean, and the Q3 is also 25% away from the mean. We can say that 4.52 divided by 2 is, since it's equal to 2.26, 2.26 is happening here, another 2.26 is happening here. That means our Q1 value is same as 92.8 minus 2.26, which is equals to 90.54, and then Q3 value is same as 92.8 plus 2.26, so it is equals to 95.06. Okay, that means we can say that the probability that the f, which is the height of the plants, is between 90.54 and the 95.606 is equal to 0.5. Okay, then we can say, since this question asks us to find the standard deviation, we still have to use the standardization, right? So we have to do the Z-score testing. So we know that Z is equal to x minus mean over standard deviation, right? So for the first part, we can say the x, which is the 90.59, or the x, which is 90.54 minus mean 92.8 divided by the standard deviation is equal to that, right? And for the second part, we can say that 95.06 minus mean 92.8 divided by the standard deviation is equal to that, right? And we know that for the first case, area is about 0.25, right? Yeah. When you think about this as a normally distributed graph, so let's do this. Okay. Then up to here, the Q1 value is 0.25, right? From the concept of the IQR. And for the Q3, we know that up to this part, the area is about 0.75. So we can say that for the first part here, the area is 0.25. Then we can set mean equal to 0 and standard deviation as 1. Then we can calculate the Z value, right, for this case using the inverse norm from your GDC. Okay, then we can set the Z value is equal to negative 0.67448, right? For the second case, we know that the area is 0.75, so means we can set the mean value as 0 and standard deviation as 1 to find the Z value for this case, which is equals to 0.67448. Then we can say 90.54 minus 92.8 over standard deviation is equal to negative 0.67448. And for the second case, this is same as 95.06 minus 92.8 divided by the standard deviation is equal to 0.67448. Then simplifying these equations will give us the equation of negative 2.26 over standard deviation equals to negative 0.67448. For the second part, we get 2.26 over d, which is, or the standard deviation equals to 0.67448. Since we know the standard deviation is equal to d, we can say negative 2.26 over d is equal to 0.67448. Then solving for d will give us the value of 3.3511. And same for this case, right? The second case, d value is still same as 3.3511. So we can say that the d value, the standard deviation value, is equal to 3.35.